Great. Thanks, Margaret. Good morning, good afternoon, everyone. Today's 30-minute session is actually the fifth webinar that MB, Michael Blumenthal, and I, Michael Campbell, MC, are doing on clinical data operations for health plan quality managers. Today, we are covering data quality and frameworks, and thus we are really very fortunate to be joined by data quality expert Charlie Harp, who is not only the CEO of Clinical Architecture, but is also the lead author of the Patient Information Quality Improvement, or PIQI framework, which he'll be discussing with us today. So let's get started with level set for today's webinar and give some context for discussing data quality. Now, we began the series with a strategic analysis of health payer financial, regulatory, and operational challenges that are really accelerating this competitive pressure that I think we're all feeling collectively in our industry, and ultimately highly incentivizing demands for clinical data that is structured, readily available, and ideally scored for data quality, including conformance with FHIR data standard and exchange requirements. So, and I've noted this in prior talks, and I want to keep re-emphasizing much of my thinking on where we are now and why modernizing our data operations must be part of every strategy to counter these competitive pressures is addressed by Lauren Diuto and her actionable findings actually of her report called System Overhaul in Motion. And the link to that report is included in the references slide that will be sent out after today. So in addition to these ongoing updates to our analysis, it seems like we have a new update every day. Today it's about Elevance. The other week it was about United. These continued kind of evidence of competitive pressures we're seeing, but we also addressed within that context current versus strategic clinical data operations. The DAMA data management knowledge areas such as data governance, as well as data user roles and responsibilities, data source inventories, metadata and its management, data lineage, and today data quality dimensions and frameworks. And so just as a reminder of what our series mantra is, data management is not an IT responsibility, it is ultimately everybody's responsibility. So just keep that in mind. Some of you may recall that I like to recommend data consultant John Werfeld on LinkedIn. And if you can have fresh takes on data strategy, he does. And he also covers data governance and data management, especially in this era of high throughput API information systems and artificial intelligence. He uses these AI whiteboards, which I love because I think they're really great references for really conceptual thinking about data management. And as an example here, John has distilled down data management to 4 key areas. Our old friends, why is it not advancing? There, data catalogs and inventories and metadata, as well as I mentioned, data lineage and data quality, the last 2, of course, which we'll be revisiting today. So starting with data lineage and its definitions, just most simply, data lineage is about understanding and documenting where data came from and what happened to it along the way. It's like a data story, its origin story and its history. Or from a functional standpoint, data lineage primarily tracks the flow and transformations of data as it moves through various systems and processes, creating a map of its journey from source to destination. And it's very useful in debugging and compliance and understanding dependencies, but it's a really key and very valuable data management technique or practice, in addition to problem solving, but also for auditability. And it actually turns out the documented data lineage of data assets is a best practice for demonstrating auditability to users and stakeholders, including your beloved internal and external auditors like myself. So again, in its simplest definition, data lineage maps the complete end-to-end journey of the instance of a data set, but it requires metadata that accurately describes the movement of that data. So you may find yourself asking, you don't know where to start. So MC, I really have no idea. So let's just start simple. Hops. How many hops in the data lineage are undertaken between the primary and authoritative source system and the target or end use case? And as in this example, 2 hops between 3 systems. Now, mappings and transformations. Within those hops, how many of them included mappings or transformations? And I'm thinking of transformation in the sense of ETL, extract, transform, load. A direct file upload to a secure FTP site, that's not a transformation, that's just a straight file upload. But it is moving from one source system to another. But if you are, say, parsing and mapping a data set into a new data model, clearly that's a transformation. So that would be one, for example, in those two examples. Frequency, how often does the data sets move from the source system to each recipient data system? You'll see here the example, source system, data warehouse daily, data warehouse to target use case on a weekly frequency. And then finally, delay. How many hours have passed between the last clinical or administrative event date in the data set and the receipt of that data set at the next information system. So starting simply with really readily available data that can generate very powerful and practical insights into the complexity of your data operations. So it's a great starting point. Now, that's a little bit about data lineage and auditability. Why is this important to our discussion today? It's important partly because Charlie and his, I will say, team of data wizards at Clinical Architecture and HL7 have identified really a critical opportunity in the transmission of standards-based CCDA and FHIR bundles, noted in this area in particular in green on the schematic above, between providers and payers. But it can also be directly between providers or between payers and payers when we have the payer-to-payer data exchange requirements coming up. Because of these kind of regulatory compliance mandates, for standards-based data sharing, these data must conform to specific versions of FHIR implementation guides such as US Core. However, we know mostly from developers that have been sandboxing in this space for some time that data availability and consistency out of these FHIR APIs, amongst a lot of the other data quality dimensions, are, I would say, generously highly variable, or very typically just described as bad. So we have a major opportunity within this data lineage journey to not only implement standardization of clinical data, but also to standardize data quality scoring and improvement. So it's keeping that in mind. Let's briefly revisit then data quality dimensions and frameworks, which we touched on in our last webinar. So I have to announce it again for those of you who are new, that it was a real gut punch for me when I discovered this as well, but there is no unified theory of data quality. So dimensions like you see in front of you of completeness, correctness, concordance, plausibility, and concurrency, these are plug and play according to what your data are and the uses you have for those data. So these frameworks have to be sensitive to your industry, to your regulations, organization, domain, and use cases. So that's the good news. You can create your own framework from your handpicked a la carte set of dimensions. But ideally, your framework or frameworks are part of a shared or accountable governance, at least locally within your organization, but preferably it aligns with ANSI SDO governed standard like PIQI, which is now under governance at HL7. So you can leverage the benefits at standardization, including things like benchmarking, and I'm sure other benefits that Charlie will touch on with us shortly. So as an example of one type of data quality framework, the 5 dimensions above, which I just mentioned, are the ones that authors Weiskopf and Wang actually recommended in 2013 as validated methods for data quality assessment for secondary use of data for clinical research. Now, without giving away the ending, because I'm about to pass the baton on to Charlie, the PIQI framework includes dimensions for availability, accuracy, conformity, and plausibility, which these are combined then together to measure and improve the portability and reusability of high quality clinical data across different systems, irrespective of the data source. Okay, so without further ado, I will pass it off to Charlie.
Thanks, MC. Am I running my slide deck from here?
Yes. Oh, sorry. I thought that's what we. I can continue to share. I thought that's what we agreed. Do you want me to reshare it?
Yeah, sure.
Yeah.
If you don't mind, I'll give you the
no problem.
Advance the slide.
It'd be an honor. All right. Okay,
right.
There we go. That's your first slide.
So when we first started researching the PIQI framework 2 years ago, it all started with kind of the same kind of a journey that MC just mentioned. Is what are the dimensions of quality? What is there a standard? Is the way of looking at it? And what I found in that research was there were some scholarly papers written about it, but I didn't find anything that I could practically apply to episodic data in flight from point A to point B. And so the healthcare data quality taxonomy, which was the very beginning of the PIQI framework journey, was built on this idea of how do I understand where quality failures happen And if you were to look at the paper that MC referenced, there are those 4 columns. And what I'm representing in PIQI is really just my version of those 4 columns. And the first is availability, the second is accuracy, the third is conformity, and the last is plausibility. And when you think about the data that we're exchanging between silos in healthcare, we don't necessarily have the reference data. All we have is some common agreement of what we're sharing and why we're sharing it. So the focus of PIQI is how do we create a rubric, a way to score and evaluate the data based upon an agreed understanding of what we intend to use and what we consider to be acceptable. Now, talking quickly about the HDQT taxonomy, you see the first is availability, and that's simply saying the data's got to be there, and this is the data that I need to be there. And the question is it populated? Is it complete? Is there something missing that should be there, which is different than unpopulated? Unpopulated tends to live at an attribute or a field level, whereas missing is something where you see a bunch of let's call them elements across a payload, and some aspect of the data is obviously missing. The next is accuracy, and that's really, you gave it to me, but is in the right format? Is it a value that's acceptable? And are the values grouped appropriately? Do they line up the way I would expect? The next is conformity, and that's because in healthcare, a lot of what we deal with are codes. And so this whole block of the taxonomy is dedicated to how we use codes in healthcare. And is it a valid member of a code set that you provided? Is it compatible? Is it what we agreed on when we decided what we were going to exchange? And the last thing is, are you sending me concepts that are obsolete? The next is plausibility. And since we're talking healthcare, we really kind of boil it down into 3 categories. Clinical plausibility. Is this something that clinically just doesn't seem right? It's outside the, is it a lab test that's not possible in a human being? Something like that. Is it temporally implausible? Did the patient have an encounter after they died or before they were born? Or is it situationally implausible? Is something about the data not possible, like a procedure performed on somebody where they couldn't possibly have had that procedure performed? Next slide, please. So when you think about data quality in the payer world, the most payer data operations teams validate data. They look for required fields, format checks, business rules, but validation tends to be binary. It doesn't measure the quality of a feed in an objective way that's comparable. It doesn't let you compare vendor A and vendor B, and it doesn't let you trend quality improvements over year. That's what I perceive as to be the gap. That's the gap that exists in the provider space. It exists in the life sciences space. And the whole idea of PIQI is not necessarily to measure the quality of the data once it's in our schema, but it's to measure the quality of the data that we're getting from somewhere else as this episodic bundle of information devoid of schema. And so it's designed to fill that gap. I sometimes think of PIQI as like a moat or a shield of my data warehouse. I want to be able to know whether I'm ingesting something that's worth the effort of trying to land it in my environment. Next slide, please. So when you think about the patient information quality improvement framework, it's not intended to just be a validation engine. In fact, it's an open methodology that we've been pushing through HL7 to get it essentially accepted as an open standard for measuring data quality. And it's been applied to patient data. We're now applying it to claims data. We're looking at applying it to payloads related to provider directory as well. Ultimately, it's a standard approach to doing scoring with the ability to use different models that flatten data into a very computable, straightforward package, design rubrics with simple assessments so that you and I can run the same rubrics on a payload of data and expect to get the same result. It evaluates data objects, claims, encounters, lab results against defined quality expectations. And it produces a score with transparent rule level detail and also awareness of where the actual failure occurred. And what I mean by that is, if I say that you should give me a LOIN code for the lab test in a lab result object payload, and the data you give me is not a LOIN code, that's a very easy failure. I can say, well, you didn't give me a LOIN code. But let's say the reason why it wasn't a LOIN code is because you didn't populate the code system. You just gave me an integer and a string, and I couldn't tell if that's a LOIN code or something else. So the failure is not the failure that you didn't give me a LOIN code. The failure is that you didn't populate a code system. The failure could also be that you didn't even fill in the field at all. And the idea of collecting the reasons why you fail, not just scoring that you failed, allows people to remediate the problem. So, the second I in PIQI stands for improvement. The idea is I can provide a score against a common rubric that we share, and then I can tell you why you failed, so maybe you don't fail next time. So the idea is a framework like PIQI makes the quality measurable, comparable, understandable, and ultimately governable. Next slide, please. So, I probably don't need to say this, but when you think about things like digital quality measures, which I know is important to the folks that are on this call, the digital quality measures are obviously sensitive to structured data accuracy. If a lab result is missing or mapped incorrectly, a patient may fail a numerator. If the encounter attribution is incomplete, the denominator inclusion might be wrong. If the vocabulary isn't normalized correctly, the CQL logic or the value sets won't get triggered, and it's going to be a no operation with the rule. These aren't measure logic problems, whether you're thinking, digital quality measures or more classic measures. These are data quality problems where the fuel for the quality measure is insufficient to drive the engine of the quality measure. Next slide, please. So this is kind of a snapshot of the Pixel Gateway, and all I'll call your attention to, these are all different data sources, and what you can see for each data source is you can see the overall score, see it at 71, 73%, the number of messages that were analyzed to produce that score, and then down below, breaking it down by each type of data object to say, well, your allergies are at 58%. Your clinical documents are at 49%. The idea of PIQI is I can break down and analyze the things that I care about when I'm receiving data, and I can benchmark that, and I can say, this is where you are doing well, this is where you're doing poorly. These types of failures indicate that there's something happening in a certain place. And that's the other area where something like the HDQT comes in handy. With the data quality taxonomy, when you start aggregating the reasons for failure, it kind of points at, is it in an engine that's producing the output format data? Is it in your fire server? Is it in the EHR or the platform that's populating the data? Are you not even collecting the data? So the idea is, if you can break all this down, you can give the source the information necessary so they can contribute the data the way that will be usable for you and your organization. Next slide, please. So when it comes to ROI, because I like to talk about ROI, in the payer space, I see that being three big areas where having something like a quality framework is beneficial. First, revenue and incentives. When you think about star bonuses, value-based contract payments, RAP protection, and they're all sensitive to structured data quality. PIQI helps make the quality of the underlying data measurable before it affects revenue. If you think about things like operational efficiency, obviously, many payer organizations absorb hidden costs from data quality issues, reconciliation cycles, chart reviews, vendor back and forth, exception handling. When quality issues are detected upstream and scored consistently, downstream remediation decreases. That reduces cycle time, manual intervention, and operational friction. And third, governance and transparency. Most plans, or I'm sure many plans, cannot objectively benchmark the quality of supplemental vendors today. And during audits or regulatory reviews, quality validation often becomes reactive instead of proactive. Standardized scoring enables vendor benchmarking and defensible reporting. It moves quality from a technical problem to a governance asset. And the last thing on this slide is really just talking about maturity. Level one is where you're reactively correcting things that are happening. Level two is you're looking at the feed and you're saying the feed in general looks good from a validation perspective. Am I seeing things? Yes, I'm seeing things. Level three introduces another dimension where you're actually doing standardized scoring against a rubric, which allows you to compare across vendors and allows you to look at your overall performance against a, let's call it an industry sanctioned rubric of this is what we expect data quality to look like. And then level four is when you start taking those types of scores and saying, you need to provide data that meets this standard, or you either can't be a data vendor or I'm not going to pay you top dollar for your data. Because the bottom line is, if you can score it, you can improve it. And I'm done with MC.
Great, thank you, Charlie. We have actually about 8 minutes for questions. So we will, I think, Margaret, if you can tell us if there's any questions coming on the board, or MB, if you have any that you're transferring in as well.
I do have, I got one question so far. It's from Tom Schenkel of Vertex Health. Question is, if I'm a quality champion with responsibility for things like stars, HEDIS, risk adjustment, how can I convey challenges and the urgency and the impact of having like more organized and structured clinical data sources, and how might I measure what that would mean to our bottom line, so I can use this type of information to try to request and maintain, annual budgets for things like data quality, with the digital quality coming and chart review retirement coming. It's a challenge as a quality person to figure out how to navigate that with so few resources. So it's a long question, but I think it's a good one.
It's a good one.
Do you want to go, MC, or want me to take a shot?
let me address one part of that, and I think, Charlie, I'd like to hear your input, particularly when it comes to ROI. Is one of the things that we try to do at Velox is we try to create, by using the metadata in the inventories, we try to show you just how complex, or I should say, in contrast, how efficient your data operations are. That's why some of the metadata we've mentioned with hops and transformations, timing, etc., that gives you a benchmarkable profile of how well you're doing currently. And obviously, Tom, in that profile of showing and comparing how you're doing compared to, say, peers or similar organizations, if you're underperforming with particular channels or data feeds, that should give then some clarity to the decision makers that we need to improve upon these. We are underperforming the industry. That's thinking more globally from discovery. I let Charlie speak to more specifics around data quality of those data channels.
I think one of the things that has always been a struggle, and this is, in the provider market as well and life sciences market, is that, people have always saying that more data is going to improve my ability. It's going to improve the clinical picture for the patient. And, empirically, that's true. The problem is when you go and get that data, the quality of that data, the usability of that data can be overwhelming. And that's another reason why we developed the PIQI framework. Is we know that more data is better if it helps improve the picture, if it fills in the pixels in the image of the patient. But the problem is there's so much noise in the data that we're getting without a way to tell that the data is actually usable quality data. It's sometimes that request backfires. We need more data. That's why our mascot at clinical architecture is the InforMonster. It's this idea that I want to pull data together and make it usable, but you end up creating this monster of information, and you put a lot of work and effort into wrangling it. The nice idea with PIQI is you go out and you get data, and it's almost like when you're shopping, you're looking for that quality tomato, right? Being able to look both with what Velox is doing and what PIQI framework is doing allows you to ensure that the view is worth the climb when it comes to trying to go and get more data.
Yes. Margaret or MB, any other questions that come in?
I don't see any that have come in.
Okay. And okay. I'll have a follow-up then, because I was interested in particular, Charlie, in the early parts of the dimensions, we discussed conformity. And I'd like to get your read on, I look at this as two kind of approaches, conformity as in conformance. And one of the benefits that I try to make sure I educate about and understand more about with fire is that because it's a standard which we can build schemas to, we can conformance test those messages that come over to make sure they're compliant with the very specific rules-based conformance schemas of fire. You also, in this case, referred to actually at the code level, which I kind of put into terminology, semantic interoperability. Is this area of conformity more broad, or is it really specific, so to be very specific to codes?
So when it comes to PIQI, this area is very specific to semantics. Because when
Okay.
one of the kind of remits of PIQI is we are agnostic to syntax. So whether you're talking FIRE, CCDA, V2 messages, CPCDS, because the standards like FIRE change over time, we're at R4, R5, R6, our objective was to really create something that measures the data, not the format of the message. Because things like Fire, you have Inferno, and you have tools that test syntax conformance. So with PIQI, we really just wanted to say, regardless of the envelope that you put the data in, can you validate that that data is usable in the use case that we've agreed upon? So it's
Okay.
the same thing, but it just in PIQI, it's really focusing on semantics.
Okay. Yeah, and I think the point that I was trying to make throughout the series is actually data quality is not just a light switch and binary, you turn it on and off, that there's different components. Understanding your total ecosystem, understanding lineage, I think is very powerful in that sense. Conformance, and again, I'm very much in the auditor mindset, like if you're using Fire and bundles of Fire, I would like to see examples of the conformance testing to show that that was a valid bundle that was used and that any validation errors with these automated systems, the tooling is really readily available, is correct. And then ultimately something where we get to that code level and determine that these instances particularly are also conformant. You discussed rubrics earlier. Can you kind of provide some clarity around, like, is there
Oh, yeah.
different types of rubrics depending on the use case?
So, a rubric, for all intents and purposes, is a collection of assessments against the model. So, it's just like when you get a test in school, the scoring is based upon a rubric. In PIQI, we have rubrics that we built for specifically for something like US CDI version 3 compliance. There'll be a rubric for US CDI version 4 compliance. We're looking at a rubric for compliance with CPCDS rules. And so really, it's just like, it's just like having a test with an answer sheet that says, this is what we required for you to pass the test in this particular use case. And so we even have facilities that have a very simple rubric for things like race and ethnicity for a statewide initiative, for example.
Okay, excellent. Okay.
We
So
do have
you
a question.
Oh, yeah,
Sorry.
go ahead. Yes,
Yeah.
please.
Yep. The question that came in is, do we want more data or more metadata? Can you speak to how the metadata produced by PIQI deployment might affect perceptions of data's usability for DQMs?
I think that a lot of the metadata in some of the work that we've done proactively with folks like NCQA and others, one of the things that's interesting about what we've been doing with PIQI is, number one, if you look at a data set and its conformance, semantic conformance is off significantly, that data will not drive a digital quality measure. You can also do something that we call signal, where you have the value sets you're using for digital quality measures. You can produce metadata that says, am I getting messages that are producing signal, where I could even drive a digital quality measure for the way these things are mapped. And so really a lot of what PIQI can do, for example, from a metadata perspective, is provide you with insights as to whether or not a particular data source is going to provide any value against a set of measures that are looking for specific things, or whether it's just not suitable to drive the measure at all. And I'm not sure if that answered the question, but maybe it did.
Yeah, it reminds me, Charlie, of your phrase, getting to quality is getting to usability. It's not this generic definition of quality. It has to be specific to the use case. So I think if any other questions come in, that's fine. But I also know we're a little bit past the end of the hour, or the end of the bottom of the hour. I just want to make sure I quickly promote our last episode in the series is coming up on March 17th, and we'll be joined by Michael Klotz, or MK for short, who is the Vlog CEO. And we'll specifically be talking more about use case fitness and ROI, because I think ultimately that's what it gets down to is there sufficient evidence of making this improvement, implementing this data quality framework, that we actually get positive and very positive ROI on our efforts. So last chance, any other questions that may have come in? Margaret or MB?
I don't see anything.
No. Okay. Everyone, thank you so much for joining us. Charlie, it was a pleasure to have you here and sharing your wisdoms and your insights. We really look forward to collaborating with you at Clinical Architecture, and to see how much we can push and drive forward clinical data quality as we really undertake this new paradigm in exchanging clinical data.
MC, thanks for having me on. I really appreciate it.
Thank you. Okay. Thanks, everyone. Have a wonderful afternoon.